Hello and welcome to today's lessons on prime factorisation, highest common factors and lowest common multiples. So first of all, we'll start from the very beginning. What is a factor? Well, a factor of a number is a smaller number that can divide that number to give a whole number result. And if you're still unsure on what that means, let me give you an example. So let's say we wanted to know if 4 was a factor of 8. So we'll write 8, we'll write 4. Now, as I said, if I divide 8 by 4 and get no remainder, 4 is a factor. So let's try that. 8 divided by 4 equals 2 with no remainder. Therefore, 4 is a factor of 8. Let's see if 5 is a factor of 8 now. So do 8 divided by 5 and we get 1 remainder 3. Because we've got this remainder, 5 is not a factor of 8. And in fact, as we can see here, 8 has 4 factors, 1, 2, 4, and 8, because they are the only numbers that have no remainder when you divide 8 by them. I also notice these factors actually pair up, so you've got 8 times 1 equals 8, and 4 times 2 equals 8. Now, it is almost always the case that you will be able to pair up these factors. The only exception is if you have a square number. So if we take something like 9, for example, the factors of 9 are 1, 3, and 9. So the 1 times 9 equals 9, but 3 doesn't have a pair because it's itself. It is its own pair. Now, before we move on, give you an example. Why don't you work out all the factors of 12? So you should have found that the factors of 12 are 1, 2, 3, 4, 6, and 12. And again, these pair up. You've got 1 times 12, 2 times 6, and 3 times 4. So, now, what is a prime number? A prime number is a number that only has 2 factors, 1 and itself. So again, let's look at some examples. 2. What are the factors of 2? Well, 1 is a factor of 2, and 2 is a factor of 2. As those are the only factors, 1 and itself, 2 is a prime number. Likewise with 3, the factors are 1 and 3. 3 is a prime number. However, if we now look at 4, 4 has factors 1 and 4, but it also has 2 as a factor. Therefore, 4 has more than 2 factors, and so is not a prime number. In fact, it's called a composite number. But now we have to ask the question, what about 1? Is 1 prime? Well, let's have a look. What are the factors of 1? The factors of 1 are, quite simply, 1. It has no other factors other than itself. Now, yes, it has itself as a factor, and yes, it has 1 as a factor, but it only has 1 factor. And because it only has 1, not 2, it is not considered a prime number. And this is very important because, now as we'll get onto, there's this thing called the fundamental theorem of arithmetic, which says that every number greater than 1 can be written uniquely as the product of prime numbers. See, I've got uniquely in bold there. What this means is that there's only one way to do it. You can rearrange the numbers around in the multiplication, but you have to have those numbers, no other numbers. So let's take an example. Let's go with 12 again. 12, as we know, was 2 times 6. 2 is a prime number. 6 is not a prime number because 6 is 2 times 3, but both 2 and 3 are prime numbers. So 12 can be written as 2 times 2 times 3. And according to the fundamental theorem of arithmetic, this is the only writing of 12. This is the only way to multiply prime numbers together to get 12. But if we allowed 1 to be prime, we could have 2 times 2 times 3, 1 times 2 times 2 times 3, 1 times 1 times 2 times 2 times 3. And in fact, we could have any number of ones we wanted in that sum, and it would always equal 12. And so for this reason, as well as what I discussed earlier, 1 is not considered a prime number. So now we move on to prime factorisation. Prime factorisation is quite simply what I've shown there with 12 is expressing a number as a product of prime numbers. So in the case of 12, the prime factorisation of 12 is 2 times 2 times 3, or you can write it as 2 squared times 3. You don't have to write it in this order, but it's standard to write it in increasing numbers, so 2s, 3s, 5s, 7s, etc. But how do you calculate the prime factorisation? Obviously, for small numbers like 12, it's relatively simple. But let's say you wanted to work out the prime factorisation of 120. Now, there are two ways of doing this. They're both very much the same method, but there's just a slight difference. So I will show you both of them. Both of them use what's called factor trees. So to start with, we've got 120, and 120 is clearly even, so it clearly has a factor of 2 in it. So I'm going to pull out that 2, and because it's prime, I'll circle it. But we can't just change our number, we need the other factor. And so 120 divided by 2 is 60, and then we just repeat. So there's a factor of 2, it's to 30, another factor of 2, it's to 15, and then that splits into 3 and 5, both of which are prime. So by this method, we get that 120 equals 2 times 2 times 2 times 3 times 5, or 2 cubed times 3 times 5. Now, I've done it there by always breaking off a prime number every time. But you don't have to do that as long as at the end all you have are prime numbers. So I could have started with here, say, 12 and 10, neither of which are prime, but they still multiply together to get 120. Now 12 I can break off as 3 and 4, and that 4 breaks down again to 2 and 2. And the 10 just breaks down to 2 and 5. And if we look here, this time we get 120 equals 2 times 2 times 2 times 3 times 5, which equals 2 cubed times 3 times 5. And you can check we've got exactly the same result, which the fundamental theorem of arithmetic says we should because it's the only result. So, your turn now. Work out the prime factorisation of 72 and 96. Okay, that should be good. So for 72, you can factor it out as 8 and 9, or you can take 2 and get 36. I'll do it this way: 8 factors to 4 and 2, 9 factors to 3 and 3, and then that final 4 breaks down into 2 more 2s. So you get 72 equals 2 times 2 times 2 times 3 times 3, or 2 cubed times 3 squared. 96. Again, I'll do it the other way this time, so you can break out 2 and 48, another 2, 24, another 2, you get 12, 2 and 6, and then the 6 breaks down to 2 and 3. So we've got 1, 2, 3, 4, 5 2s and a 3. So 96 equals 2 times 2 times 2 times 2 times 2 times 3, which equals 2 to the 5th times 3. But why do we care? What can we do with this? Well, one of the things we can do with prime factorisation is work out highest common factors and lowest common multiples. So to start with, let's define what each of those is. So, what is a highest common factor? A highest common factor is the largest number that is a factor of both of two numbers. So for both of these, for highest common factor and lowest common multiples, we're discussing it with regards to two numbers, or two or more, but you'll only ever see it for two. So for example, the highest common factor of 6 and 9 is the largest number that goes into both of them, which is 3. What about lowest common multiple? I can spell, do apologise. So the lowest common multiple is almost the opposite. It's the smallest number that has both of your two numbers as a factor. So the lowest common multiple of 6 and 9 is 18. It's 6 times 3 and 9 times 2. And there is no number smaller than 18 that is a multiple of both 6 and 9. How can we find these using prime factorisation? So, let's go for 15 and 24. So 15 is 3 times 5, and 24 is 2 times 2 times 2 times 3. And what we do is we draw out a Venn diagram, like so. So this side is all of the factors of 15, and this side is all of the factors of 24. And what we do is we start by filling in the overlap, middle. So, both numbers have a prime factor 3. So we write the 3 in there, and then we can cross it off our lists. And that's all they have in common. So on the left-hand side here, we can put in our 5, and on the right-hand side, we can put in our 3 2s. Now, the highest common factor of these numbers is everything in this section here in the middle. So, in this case, the highest common factor, you'll normally see abbreviated to HCF or sometimes GCF, greatest common factor, in this case equals 3. And the lowest common multiple, well, that is everything in the entire diagram. So that, in this case, is 2 times 2 times 2 times 3 times 5, which, as we saw earlier, equals 120. Okay, so your turn now. Work out the highest common factor and the lowest common multiple of 60 and 81. Okay, so let's start at the beginning. What are the prime factorizations of each number? Well, 60 is 2 times 2 times 3 times 5, and 81 is 3 times 3 times 3 times 3. Write that 3 a bit better. So, again, we fill in the middle. Both numbers have a 3, and that's all they have in common. So then on the left, we can put in our 2 2s and our 5, and on the right, the other 3. Okay, now, the highest common factor, as we said, is this middle section, which in this case is just 3. And the lowest common multiple is everything in the diagram. So it's 2 times 2 times 3 times 3 times 3 times 3 times 5, or 2 squared times 3 to the 4th times 5. And you can probably use a calculator for this, but you should get that it equals 1620. Well, that's it for today. Thank you very much for watching. My next lesson will be on listing. I'll explain more in the video, but that's basically how many different ways are there of doing something.